Hello everyone and welcome. This is the CyberSecStudy CISSP video bootcamp series. You're watching the free version of this domain. For access to the full version, go to the website at www.cybersecstudy.com. So hello everyone again, my name is Donald Parker. The reason you're watching this video is because you're interested in obtaining the CISSP certification, and in some cases you need it, right, for your job. The reason I'm here is because I developed a training program that can help you get past this doggone exam. So the program consists of a book of the course material, audio recordings of all of that content in the book. We have the video recordings now of all of the content of all 8 domains. I developed a Jeopardy style game that has questions that are based from the course material, and then a Kahoot competition style game where folks can compete and test their knowledge of the information in the course material. So this is a copy of the book. It's a little thicker than I really wanted it to be. But this is a hard copy version of the course material. If you purchase the audio or the video, then I'll also give you a soft copy of this course material. So for the book, it took me several years to write this book. I used several sources. The common body of knowledge, of course, the CBK is the most authoritative source. I also used the late great Sean Harris's all-in-one study guide. It's a phenomenal book. I used several practice question exam books that had explanations, very good explanations of key terms and concepts, and then the internet, of course. So I went through all these sources. I tried to group together the smallest grouping of terms that I thought would help you pass the exam. So I tried to, I categorized all these terms into either just terms, informational notes, concepts, and something I call muscle memory, which is all those algorithms and the OSI model and the ports and protocols and all that stuff that's just muscle memory that we have to memorize. I broke that out separately so that you could print out those muscle memory charts and focus on the muscle memory separate from understanding the terms and the concepts that I want you to know. So the focus of my book, of this course material, is to identify key terms and to expose you to those key terms in many different ways. I went through a couple of boot camps myself. I've taught boot camps with other people's course material, and what I've felt from those classes is that they were just throwing a bunch of information at you, just a ton of information. There's no way any of that stuff was sticking. So the intent of my program is to identify key terms so that when you're taking that exam and you're reading a test question, you see 3 or 4 key words, and those will point you to the correct answer. So we go through, as you go through this video series, you'll see these and hear these key terms. When we play rounds of Jeopardy, they're focused on these key terms. And when you test your knowledge with Kahoot, you're going to see these key terms again. So multiple times you're seeing these key terms and they're just embedded in your brain. So you could purchase the book, read the book. You could listen to the audio, which is just a verbatim, word for word illustration of the book. You can read or listen to the audio and follow along in the book at the same time. You could purchase the video series that you're looking at now, the full version of the video series for all 8 domains, which is the video recordings are a recording of a boot camp we just finished a couple of weeks ago. It turned out a lot better than I expected, and I think it can be really helpful. You could also watch or compete in rounds of Jeopardy, which, after you've gone through all the material and you're ready to see where you're at and test your knowledge, there are 15 rounds of Jeopardy to get through all 8 domains. But then Kahoot. Kahoot is something that we do on a weekly basis in the evenings. You could, if you go to the website and purchase the ability to compete in one of these competitions, there's one for each domain. The number of questions varies, but after you compete in this competition against other people who are preparing for the exam, it gives me a spreadsheet of every question and every answer, whether you answered wrong or right, so that I can sit down with you and know where you're weak and where you're strong. The people who compete well at Kahoot pass the exam the first time, every time. So the question that I often get, I think I get more often than any other question is, what's my success rate? How many of my students actually pass the exam? So I've been teaching CISSP boot camps with my own material for about 5 or 6 years. I've been teaching the boot camp for over 10 years, but all of my students pass the exam. If you go through my entire boot camp, I can tell you with the Kahoot rounds and the printout, the spreadsheet that comes out of that, I can tell you whether I think you're ready or not. If you're ready, you take the exam, those people pass every time. If you're not ready, I'll tell you, and I'll tell you what I think you need to work on. Now, I've had some folks who took the exam anyway, even after I told them that I think we need more time. They didn't pass the first time. I worked with them some more afterwards, and they passed the second time. So really, it's up to you. If you can get through all of this content, it's a marathon of material to get through. If you really want it, if you really need it, then if you can get through all of this content, I am very confident that you can get through the first time. But I would need to see you compete on Kahoot rounds in order to know for sure whether I think you're ready. All right, guys, that's it. Welcome to the program. Welcome to this journey to cybersecurity. It is the fastest growing industry in the world. It's the most exciting, in my opinion. I love what I do. I love working with this stuff. I love talking about it. I love sharing information. So again, if you're interested in the full version, go to www.cybersecstudy.com and take care. All right, guys, domain 4, communications and network security.
So,
it's not a driver issue, just flat out no.
It's not compatible.
OSI model.
They are now, though.
Most important muscle memory chart of them all, in my opinion. 100% on the Yeah.
Oh, yeah.
Anybody recognize this thing here? Within the thing you just said earlier? Hold on a second. It's that guy in the back.
That's
Nikola Tesla, the greatest mind ever to live
Who
in
died
this
broke?
universe.
Who died broke? Who died broke,
So
yeah.
how do they start Tesla then? Did they just take his designs?
No, this was Elon Musk
Oh.
to honor Nikola Tesla.
Okay, that's why you say that.
Because Nikola Tesla was walking through the park one day, and in the stand drew out the map of an electric motor. You know how you have the magnets on both sides, and you send a pulse of energy on that side, and that's what makes all electric devices we have that have an electrical motor are operating off of what Nikola Tesla invented. He invented remote control.
Wow.
He invented the AC power system. He invented a remote power system. We shouldn't have to plug anything up to get power if we were using his system. He came up with the idea for remote power.
Wow.
Years ago, and because Thomas Edison and Carnegie Mellon and all those other rich
General Electric
couldn't make money off of it, they prevented it from happening.
He worked for Edison, and Edison told him, "Oh yeah, if you could solve this generator problem, I'll give you 50 grand." And when he solved it, he was like, "Good job. Where's my 50 grand?"
You don't understand
Tesla,
American
yeah,
humor.
yeah. I guess you don't know the American humor.
So
So you quit.
telecommunications, the prefix tele means distance. So telecommunications means communicating from a distance. So you're not supposed to say I'm telecommuting. If you mean you're teleworking, telecommuting means you're commuting from a distance. That means you live in the suburbs and you're commuting in from a distance. If you're teleworking, that means you're working at home or working from a distance. But telecommunications was different forms of it back in the day were smoke signals, a form of communicating across a distance, microwaves, routers, switches, cables, satellites, the internet is the way that allows us to telecommunicate. Binary notation. All computer systems work, and so any letter or symbol can be expressed as a sequence of zeros and ones. And then you send that pulse of energy across the cable. A pulse of energy equals a 1. No pulse of energy is a 0. Pulse of energy is a 1. You can store information in a hard drive, and all these little rows and columns of little cells that can either be energized or not energized, ones and zeros. A bit is a single unit of information expressed as either a 1 or a 0. How many bytes or how many bits in a byte? 8 bits in a byte. That was the only thing I remember from my bachelor's degree. that and the phrase Fortran compiler. All right, protocol. We've seen that term already. In cryptography, a protocol would tell us or tell an algorithm how it would operate. In telecommunications, a protocol is going to determine how information is transmitted from one system to another. Protocol is a standard set of rules that determines how systems will communicate across the network. Application APIs, as cloud computing begins to gain more and more momentum, APIs are also gaining more notoriety. They serve as an interface between different software programs and facilitate their interaction. Does anybody recognize the difference between an interface and an interconnection? Is there a difference? When I interface with the system, I can interface with my mouse, I can interface on the keyboard, he's interfacing with the touch screen. But when I interconnect with another system, my system is connecting to another system, usually to send information back and forth. So an interconnection is between two systems. An interface is how you or a computer program could interact with a computer system. I see that those terms mixed up a lot. Encapsulation and decapsulation. So we have the OSI model here, the layers of the OSI model. We'll talk about these in just a minute. But if you're working at an application that is at the application layer, the application itself is not a representation of the application layer. But when you're working on the app, you hit send, that message goes down the OSI model from application to presentation to session, and each layer it goes to, information, additional information is attached to that packet, and that's called encapsulation. So you encapsulate and add more information to that message as it goes down the stack. Then when it gets to the physical layer, it connects to the wire, and that message is sent across the wire. It reaches the other computer, and as it goes back up the OSI model, it's decapsulated. Those layers of information are taken off as it goes up the OSI model. So you just need to be able to recognize that encapsulation is from layer 7 to layer 1. Decapsulation is from layer 1 up to layer 7. The OSI, well, just not necessarily OSI, but the reference model in general. Wikipedia says a reference model is a model of something that embodies a basic goal or idea of something and can then be looked at as a reference for various purposes. What is the overall purpose of a reference monitor? Anybody have any ideas? Why do we even have the OSI model or the TCP/IP model?
For troubleshooting purposes.
Okay. Yeah. But in general, we have it because there are so many different types of computer platforms. There are so many different types of computer languages, so many software developers that use different tools that develop different programs, different protocols, different ports, different services. In order for all those different things to be able to communicate, we have this reference model so that all these different types of things can communicate. So the OSI model provides a framework, that word framework, for how messages should be transmitted between any 2 points within a telecommunications network. A layer provides services to the layer above it and receives services from the layer below it. Since there's so many software developers using so many different development tools and languages with applications that communicate with other applications in different ways, and users who interface with applications and data in different ways, the ultimate purpose of the OSI model is to ensure that developers and their products can work together. OSI has 7 abstraction layers. How many layers does the TCP/IP model have? 4. 1, 2, 3, 4. We'll talk about each layer briefly, but the muscle memory chart that we have is where almost all the information is we need to know. You need to recognize these. Does anybody have a mnemonic for how to go from layer 7 to layer 1? What do you got?
Please do not throw sausage pizza away.
Okay, and how about going from layer 7 down to back to layer 1? Or you just use that same one for both?
Yeah, it was something I heard years ago, and I never forgot it.
Need Donald Parker.
There you go. Oh, my man. Oh, my man. He's been studying. He's been studying. That's my mnemonic. All people seem to need Donald Parker. So data link layer is the Donald layer, physical layer is the Parker layer, and then Parker, Donald needs to send people away. I use one for going down and up. I wish I could say send kids away. But, I love the kids. I love working with kids. If I could work full-time training kids, that'd be my favorite job. All right, so let's talk about each of these. Things we need to know are in the muscle memory chart, but there are a couple of key points that I want to point out to you guys. Application layer, layer 7 OSI model doesn't represent the actual applications. It does represent the protocols that support applications, so we need to know what protocols operate at this level, what services are provided at this level, some of the services, print service, database service, file service, application service, some of the protocols, SMTP, HTTP. That one's pretty easy. The presentation layer, layer 6 of the OSI model, responsible for formatting and delivery of information to the application layer. So you imagine information coming up from layer 1 all the way up to layer 6 before it gets to the application layer where the applications are. It wants to format that information because each application receives information in a different format. So we want to present that information to the application layer in the correct format. It focuses on the syntax and format of data. Session layer, layer 5 of the OSI model, is responsible for managing the connection between 2 applications. Make sure you highlight and remember that. Session layer deals with the connection between 2 applications, whereas the transport layer deals with the connection between 2 computers. Session layer, applications. Transport layer, 2 computers. Network layer of the OSI model, layer 3, is responsible for choosing the best path for routing packets of information. So some of the protocols, ICMP, RIP, IPX. That's the most important thing we need to know. It's responsible for choosing the best path for sending packets of information. The data link layer, the Donald layer, is the only OSI model layer that has 2 sublayers. Okay, and it's also the only layer that has 2 names, 2 words in its name, data link, whereas all the other ones are just 1 word, right? So that lets you know that data link is the only one that has 2 sublayers. And I remember questions asked, which is the uppermost sublayer of the OSI model? LLC, logical link layer, is the uppermost sublayer of the data link layer. Provides multiplexing. We don't need to know all that. That's a little too much detail. Then we have another MAC, media access control. This sublayer determines where one frame of data begins and the next one begins. So, and we're going to talk about this in a minute, but if you have multiple computers connected to one wire, only one computer can send a message down that wire at a time. If you get 2 computers trying to send a message, 2 computers sending electrical charges down that wire, then they're going those signals are going to collide. So you want to have a mechanism that can make sure that 2 computers aren't trying to communicate at the same time. So this MAC, message or media access control, accessing the media, controlling how computers access the media, making sure that there's no collision. And then the physical layer, layer 1, is comprised of the hardware components, such as wires, routers, well, not routers necessarily, network interface cards. A device that works at the physical layer is called a repeater, is a device that works at the physical layer. It allows you to send, amplify the signal. And we'll talk about some of the problems why you would need a repeater. This is a very important muscle memory chart. I always tell folks, you know, print out these muscle memory charts, have them ready. When you start doing practice questions, you can refer back to these muscle memory charts and make sure that the information is correctly jotted down in here. You may see information from a practice question that you realize needs to be added into here. So go ahead and do that. I need to confirm whether this information right here is still correct. But what this is saying is, if a user at the application layer sends a message, it's going to be encapsulated as it moves down here, but it's called a message. At layer 7, 6, 5, and 4, that packet of information is called a message. When it gets to layer 3, it's called a datagram.
No, it's actually packet. 725 is message, 6 is segment.
725?
Okay, 765.
765 is message.
4 is
Segment.
Segment, and then network is correct and frame is correct.
Is it network or packet?
Yeah, datagram. They call it datagram or packet.
Same thing.
Yeah. And then yeah, frame.
All right, let me make sure we got.
It's also in your slide, your previous slide.
This one says stream, segment / datagram packet frame.
What segment for transport, right?
Yeah. The other one's your data stream.
It's in your previous slide.
It says look for more information on Wikipedia.
Previous slide or the next slide?
No, previous. Like when you opened it, it was on there.
But again, some of these are all subjective. Because you'll find another book, it'll call it slightly different.
Yeah, and that was my problem.
Yeah.
Every source I went to had it listed differently. Oh, here we go.
Yeah, there it is. See? There you go.
Oh, okay. So data. Segments, yeah, packet, frames, yeah.
That's what I saw.
Data link is called a frame.
So I'll go with packet for network and not datagram, because datagram is also the same thing.
Right.
But you'd be lucky to get questions like this.
Oh yeah.
Yeah,
You don't recall seeing anything like that? Okay.
Yeah, that's an easy one.
Yeah.
They're not like one-word answers, right?
Yeah.
They're more complicated than that.
But I'll tell you though, when you're reading a question, and it refers to information as a frame, then you knowing that the frame is at the data link layer can help you answer the question correctly, right?
The inference.
The inference, if they talk about a packet or they call it a segment or bits, then you know what layer of the OSI. Just knowing that can help you. They may not give you all the information you need, but just that one keyword can tell you what the correct answer is. All right, so TCP/IP model does the exact same thing as the OSI model, just fewer abstraction layers. Remember our definitions for classifying information? Remember we said the first one was too many classification levels would be confusing. Too few classification levels would make it seem like it's not necessary. So the fewer layers, the better. The fewer classes, the better, in my opinion. OSI model, I think, has too many layers. It kind of gets confusing as to what protocol should. And a switch can work at layer 2 or layer 3, right? We'll talk about that and why that's possible. But I like the fact that there are only 4 layers. And they do the same thing as the OSI model. We just need to know the names of these layers. That's what I struggled with on the exam, remembering the names of the TCP/IP layers. But then we also need to know, I remember questions that said, which layer of the TCP/IP model corresponds to the presentation layer of the OSI model? So this is a muscle memory chart we need to be able to write down. And having this 3112, does anybody know why that's there?
Number. Okay, please.
The number of corresponding OSI model layers, right? I had a class where nobody could see that correlation. Nobody got it. I mean, we spent a long time pointing out that the top 3 layers of the OSI model do the same thing as the top layer of the TCP/IP model. And then there's a one-to-one correlation between transport and host-to-host, one-to-one correlation between network and internet, and then the bottom 2 layers do the same thing as the bottom layer of TCP/IP. Come up with a mnemonic and be able to write this down. But 3112 can help you with that. Then all you just have to remember is the name of the TCP/IP layers.
All right.
See you guys on the phone.
Take care, Don.
Enjoy football the rest of the weekend.
Thank you.
American football, I should say, not real football.